In this presentation, we will explore how to detect the presence of the functional group of alkyl halides, which is known also as halogenoalkanes. So we have a hydrocarbon chain, and we have one of the halogen atoms bonded to this chain. So actually, we are testing for the presence of bromine, chlorine, or iodine. First of all, we will add sodium hydroxide and we will warm up the solution. Then we will add nitric acid, HNO3, to acidify the medium. And then we will add silver nitrate, AgNO3. So now we are adding silver nitrate and we will shake. A white precipitate indicates the presence of a chloride, Cl-. We are adding also silver nitrate, however this time we obtained a cream precipitate which indicates the presence of bromide, Br-. And when we obtain a pale yellow precipitate, this indicates that the ion present is I-, iodide ion. So if there is a halogenoalkane in this solution, after adding silver nitrate, we will obtain a white precipitate. If the halogen is a chlorine, we will obtain a cream precipitate if the halogen is a bromine, and we will obtain a pale yellow precipitate if the halogen is iodine. So let's match the halide ion to the color of its precipitate formed with silver nitrate solution. What is the color of the precipitate if we have a chloride, if we have a bromide, or if we have iodide? Excellent. So if we have a chloride, the color of the precipitate formed with silver nitrate is white. If we have a bromide, it will be cream, and if we have iodide, it will be pale yellow. Let X- be any halide ion. The general ionic equation is Ag+, which is aqueous, plus X-, which is the halide ion aqueous as well, will produce a solid precipitate of the formula AgX. So what compound is precipitated in the test for an iodide ion? Excellent. So the compound will be silver iodide, AgI. Let's now complete the following equation. Ag+ and Br- will produce, so write the compound of this precipitate. So the precipitate is silver bromide, AgBr, which has a cream color. Actually, the differences between the colors of the precipitates of silver chloride and silver bromide are difficult to see unless you have both together to compare. To help distinguish them, we can add dilute ammonia solution, NH3. Silver chloride dissolves in ammonia solution, but silver bromide is insoluble. Actually, silver bromide will dissolve in concentrated ammonia solution, but silver iodide, AgI, is insoluble even in concentrated ammonia solution. So, silver chloride is soluble in dilute ammonia. Silver bromide is soluble only in concentrated ammonia, whereas silver iodide is insoluble in dilute or concentrated ammonia solution.